Okay. I hope my screen is visible to all of you.
Yes, sir.
Yes. Okay. So these are the charts which was uploaded in the classroom. Surface tension chart 2 and 1. There is one link for simulation and one video I have uploaded so that you will get a crystal clear idea about this experiment. Now moving to the chart 1. Okay, so these are the charts which were taken by the lab attendant. So it's not clear too much, but I'll try to explain the other things which are mentioned in the chart. So these are the things which we need to check: the surface tension by capillarized method. And in that case, we need to determine the surface tension of a biological fluid or pure water. In this case, we are considering. And this is the formula. Can you see the formula, everyone?
Yes, sir.
It's T equal to HR rho G upon 2 cos theta. So in that case, R is the radius, then H is the whatever capillarized in that liquid, rho is the density of that particular liquid. Let's say if you consider the water, then it's 1 kg per centimeter cube. G obviously acceleration due to gravity. In CGS it is 980, and if you consider in MS system or SI system, it is 9.8 meter per second square. And obviously the angle of contact. In this case, whatever water we are considering, that is tap water or pure water, angle of contacts might not be zero, but still we are assuming whatever water we have taken, that is pure, and angle of contact is zero. So that cos theta will be 1 as theta equal to 0. So your final formula will be RH rho g upon 2. RH rho g upon 2. I hope this is clear, everyone.
Yes, sir.
Okay, simple one. And the procedure, before going to that detailed procedure of the laboratory, me come back to the experiment. Okay. Can you see these images, everyone?
Yes, sir.
Please understand or please listen carefully what I am saying. This is important part. Now, for that experiment, capillary rise method. Obviously, capillary rise method through that capillary. A capillary, you know, a glass tube which is having small bore or small radius, very small radius. Okay. Now, in that case, if you want to measure its radius, what we are going to do? We are going to measure the readings of the traveling microscope. First on the left side, then the right side, and on the top and on the left side, so that you will get the difference between the top reading and bottom reading. That will give the diameter, and obviously half of that will give the radius, that is in millimeter. In simulation I will explain that process, how to measure this. Now observations, the least count. What is the least count of traveling microscope?
0.001 centimeter.
0.001 centimeter. Okay, how do you done that? It is smallest division on main scale divided by total number of division on vernier scale. What is smallest division on main scale?
0.1.
0.1. Okay. Okay, I'm not allowing this guy, Om Narkar. Okay, it's 825. Okay, 0.1 or in some. Okay, let me show you one traveling microscope so that we will better understand. And then we will take those two readings for radius and diameter. And this table I will explain. So let's go to the simulation. Can you see the simulation, everyone? Hello, Jatit, Munal.
Yes, sir.
Yes, okay. So there is one theory at the top: theory, procedure, animation, simulator. Now let me maximize the screen so that we'll better understand this column. Okay, can you see these columns? Select solution.
Yes, sir.
So water, 6 molar salt solution, and 2.55 molar sugar solution. So water, then select environment. So different planets are there. Right now we are on Earth, so I will take as Earth. Now select temperature. Can you see this variation from 10 to 90 degree? Everyone?
Yes, sir.
Yes, okay. This you can see. Then capillary tube diameter. Okay, let's we if I click on that link, capillary tube diameter, you can see it's going to be increased. Okay, let me show you in this magnified image so that you'll better understand. Okay, can you see this capillary? The eyepiece part,
Yes,
which
sir.
is from here. Now let me change the capillary tube diameter. You can see its variation. It's very small, 1 to 2 mm only, but still you can see the changes. And height of the wooden stand. So basically it consists of a stand, then the rubber cork, the capillary tube, which is there, the needle. This is the drawing microscope, and these are two scales. This is the horizontal scale, and this is the vertical scale. So let me click on that link so that we'll better understand about the scale. Okay, can you see the scales?
Yes, sir.
So this is the main scale, and this is the vernier scale. Now you can check the vernier scale, which varies from 0 to 30. We need to go up so that you will better understand. Okay, till 15 also you can check how to take those readings. So the bench scale reading, which is the line which is coincide to the Vernier scale 0, and for Vernier scale reading we are just checking which number of line out of the 30 line is matching with the main scale exactly. You can see these lines are not matching. Let's say this is number line 10, this is 11, 12, 13. This is not matching exactly to the main scale. I'll explain that process once we go with the readings. Then this is the height of wooden stand. You can see there is a variation height of wooden stand. Then the level of retort stand also varies. The focus of the microscope. Can you see the variation? Now image is getting blurred. Madhura, Tejaswini.
Yes, sir.
Yes,
Yes.
sir. Yes, sir.
Next, height of a microscope. Now you can see the variation. The microscope is moving. We are taking vertically or we are moving it vertically. That's why we need to take vertical readings. If it is moving horizontally, then we need to consider horizontal readings. I hope this is clear. This we need to check, okay? Which part it's doing. Then show result, obviously it will give the value as 0.074 Newton per meter, or in CGS, you know the conversion factor. Yes, anyone? Conversion factor of Newton to dyne. 1 Newton equal to how much dyne?
10 raised to 5.
10 raised to 5 dynes. Okay. If we substitute in that equation, we will get this reading 0.074 as 74 dynes per centimeter. Okay. And there is one option which is remove beaker. If you click on that, the beaker will get removed, and finally the reset, so that it will come back to the original condition. Okay. Now look at carefully what I am doing. I'm mentioning the case so that you'll better understand. First, I will take water as a solution. and 6 molar salt or 2.55 molar sugar solution also you can take for a practice. But right now for this experiment, we are taking water as a solution. Obviously environment we are taking as earth. I hope I am audible to all of you. Jatin, Vaibhav, Nimisha.
Yes, sir.
Yes. Okay. Now select temperature. Now we can vary the temperature from 10 to 90 degrees. Right now I am showing you the readings for 10 degrees. Okay. So I will keep it as 10 degree. Capillary tube diameter, I am keeping it fixed 1 mm. I am not changing the scale. And the height of wooden stand also I am keeping as a fix 5 centimeter. The level of retort stand also I am keeping fix. Now the focus of microscope I need to vary because you can see on the right side I can see the blurred image. If I want the focus sharp image, obviously I need to decrease this. Okay, can you see this sharp image now?
Yes, sir.
Yes. Then the height of the microscope you need to check. Now, what are the conditions before starting the experiment? Now, you know the value. What value you are going to supposed to get? Around 74 lines per centimeter. So, before performing the experiment, before performing the simulation, you know the values. So don't tell me, sir, I have got 180 or 43 lines per centimeter. Okay, then you can cross check. Obviously, it's simple, logical sense. Now, as I mentioned, first condition, whatever which I am doing, is select temperature. Okay, just wait. Select temperature as 10 centimeter, 10 degrees Celsius, not 10 centimeter. Kepler tube diameter, I'm keeping it fixed. Height of wooden stand fixed. Retort stand fixed. Focus of microscope, I have just minimized so that you will get a sharp, clear image. Now, height of the microscope, I'm changing. Now, before doing that, you can see the capillary and the one pin in that beaker. So let's click on that link on the beaker. Okay, can you see this image, maximum image?
Yes, sir.
Yes,
Okay.
sir.
In that case, understand carefully. We need to dip this tip of the pin in such a way that it just touches to the water surface. Again, I repeat. In that case, there are two things: capillary tube and pin pointer is there. We need to adjust this pin pointer in a such a way that that tip of the pin just touches to the water surface. I hope this is clear. Then and then we are able to measure this height difference. Whatever rise in that liquid, we are able to measure. This is the case. So this is measured as a standard reference, you can say, before touching to the water or before entering into that water. Now we know that capillary once it dip into that liquid, the water will get rise up at particular height depending upon that temperature. We will study it. But this is the condition. So I'm clicking on that cross. I'll come back to the original experiment. Now on the right scale, you can see on this zoom part, you can just see whatever I'm doing. Okay, can you see the meniscus, everyone?
Yes, sir.
Okay. Now I need to adjust this meniscus or the crosswire. This is the crosswire which I am able to see through the eyepiece. Okay, this eyepiece part is magnified on the right side in a such a way that the center of the meniscus just touches to the crosswire. Now you can do from this for a manual reading, and if you go for a fine tuning, let's say for fine tuning, you can see this screw. Can you see this hand symbol?
Yes, sir.
Okay. Now if I click on that link, you can see it's moving finely. Exactly, I'm getting the readings. Okay, so this is the part which I can say. You can say this is the fine tuning buttons. Now, what is the height in this case?
6.35.
6.35 centimeter. That you are going to write in the second table. Now, before that, let me cross check this reading. Okay, let me show you the reading, how it's come to the 6.35. Now we know the reading from this. How to take that reading from vernier scale or the traveling microscope? You need to click on the traveling microscope. Okay, can you see these readings, everyone?
Yes, sir.
Yes, sir.
Okay, so on the main scale, please listen carefully what are I'm saying. This is very important part. Now on the main scale, you can see 6.25 and this is 6.50, and there are 5 lines in between this. Now this number of line, what is the reading for this line?
6.30.
6.30. Okay, so there are 5 lines in between that 0.25. So 0.25 divided by 5. So each line corresponding to 0.05. So it is 6.30. This is 6.35, 40, 45, and 50. I hope this is clear. Vaibhav, Nimisha,
Yes, sir.
Aska.
Yes, sir.
Okay,
Yes, sir.
I'm showing you the readings. Either we have studied in first year also, but still you can cross check. So you can see this is 6.30, 6.35, and that 0 of the vernier scale is not cross the 6.40 readings of the main scale. That's why we have taken 6.35 as the main scale reading. Clear, everyone? It is in between that
Yes, sir.
6.5 and 40. So 6.35 is the main scale reading. Now vernier scale reading I need to check. So you just need to tell me which number of line. You can see there are a lot of lines 0, 1, 2, 3, 4, 5. Which line is exactly matching with the main scale readings? Just check and let me know which number of line is exactly matching. Any line is matching? Anyone can see the difference? Which number line of
The
matching?
30.
30.
30.
Okay.
30.
You can see this 30 number of line is clearly matching with the main scale reading. Okay, you might have seen a different number of lines which is matching with the main scale, but you need to consider the line which is matching first. Let's say 8 number line match हो रहा है, 20 match हो रहा है, 25 भी match हो रहा है. So you need to consider the number 8 line, okay, which is first coincident with the main scale. So out of those 50 lines, you need to check. But right now, as we have discussed, the line number 30 is exactly matching with the main scale. So what will be my reading? 6.35 main scale reading plus vernier scale reading into LC. This count we know 0.001 centimeter. So 6.35 plus 30 into 0.001 centimeter. That will be my final reading. Is it clear, everyone? The main scale
Yes, sir.
reading we know 6.35. Now look at the chart which I am explaining. 6.35 vernier scale reading is 30. Final reading is 6.35 plus 30 into 0.001 centimeter. That will give me total reading, and this is the H1. Height rise as a H1. How to measure H2? Again, coming back to the simulation. This part I am closing. Okay. Now 6.35 right hand side you can see the condition. The crosswire just touches to the center of the meniscus. I will go down. I will click on that remove beaker. Okay. Now I need to focus on the tip of the pin. What I will do? I will just increase the focus of microscope. Okay. Can you see this tip? Needle.
Yes, sir.
Now again, I need to adjust the crosswire in a such a way that it just touches to the tip of the pin. Now again, I need to change the height. You can see the variation. Again, for fine tuning, you can use this screw, vertical screw. Using that, it's getting fine. Okay, how much reading right now?
3.35 centimeter.
3.35 centimeter. Okay. Again, you can cross check. You can click on that vernier scale. Okay, let's me go back to the brown. This part takes some time in order to get scroll because there is no button which they have given. But still we can check. Is it exactly 3.35 or anything else? Yes, we have got the vernier scale 0. Yes. Can you see this, everyone?
Yes, sir.
That's 3.25. Obviously, the next one is 3.30. This is 3.35. It is just above that 3.35. That's why we have taken 3.35 as the reading. So again, 3.35, the line, vernier scale line, which is matching with the main scale, you need to check.
Sir, it is 15.
It is 15. Okay, let's say 15 or 15 number of lines. So it is the final reading will be what? 3.35 plus 15 into 0.001. Okay, so your main scale reading is 3.35. Vernier scale division is 15, and total reading will be 3.35 plus 15 into 0.001. That will give the H2. And the difference between H1 and H2 will give the H, that is the height difference. And then obviously you can substitute that H in that formula, R H rho g upon 2 cos theta. R, the capillary tube diameter, you know this is fixed, which we have keep fixed in that experiment. Let me check what is how much the value. Okay, you can see this capillary tube diameter 1 mm. Now we want radius, so radius will be 0.5 mm millimeter. So my R is 0.5 mm. It is fixed. H, whatever difference you have got in that case. Rho, density of water is 1. G, 980 centimeter per second square, and upon 2 because cos theta is 0 and cos 0 is 1. Okay, I hope this part is clear. Shall I repeat one more reading?
No, sir.
Everyone understood? Tejaswini, Harsh, Madhura. If you are not understood, you can say me right now. No problem. I can repeat. Vaibhav, Pauna, Siddesh, bola kaitri, Atska.
Yes, sir, understood.
Understood? Okay.
Understood, sir.
Understood.
Okay. What you need to do? Okay, again I'm closing this. The water as a medium you need to take, and you need to consider any 3 temperatures. We are cross-checking that whatever hypothesis which are made, that it would decrease with the temperature. The first reading you need to take for 10 degrees Celsius. The next readings you can take with your choice. You can take 20, 50 or 60, 80, 60, 90 also you can take. Clear this part, everyone?
Yes, sir.
Yes, sir.
Yes, okay, good. Any doubts?
No, sir.
No, sir.
Okay, now let me show the video so that we will better understand about the experiment. Same experiment which we'll going to perform in lab. Okay, can you see the video? Everyone?
Yes, sir.
Okay. Can you hear the audio?
Yes, sir.
Okay. I'm muting my mic. So, okay, or parallel I can explain.
Surface tension. Surface tension is the property of a liquid by virtue of which its free surface at rest behaves like an elastic skin or a stretched membrane with a tendency to contract so as to occupy minimum surface area. The ability of some insects, such as water striders, to run on the surface of water is due to surface tension. The effective method to measure surface tension of a liquid is through capillary action, since the capillary rise depends on the surface tension of the liquid. Now, let's find out the surface tension of water by capillary rise method. Principle. When a capillary tube is dipped in water, the water rises through the tube and makes a concave meniscus with the tube. The weight of the liquid below the meniscus is supported by the surface tension of the liquid acting around the circumference of the point of contact. That is, 2 pi RT cos theta is equal to pi r squared rho g into h plus r by 3. Or T is equal to h plus r by 3 into r rho g divided by 2 cos theta, where T is the surface tension of water, H is capillary rise, R is radius of the capillary tube, rho is density of water, theta is the angle of contact between water and glass, G is acceleration due to gravity. Materials required: glass capillary tube, a beaker containing water, a pointer, adjustable wooden stand, clamps and stand, traveling microscope. Procedure: place an adjustable wooden stand on the table. Place the beaker containing water on the wooden stand. Fix the capillary tube and the pointer on a cork and clamp it on a stand so that the tube and the pointer become vertical. Adjust the height and position of the stand so that the tube dips in water in the beaker. Adjust the position of the pointer so that its tip just touches the water surface. Place the traveling microscope in front of the arrangement. The least count of the microscope can be found out using the relation. Least count is equal to value of 1 MSD divided by number of divisions on vernier, which is equal to 0.5 millimeter divided by 50, which is 0.01 millimeter or 0.001 centimeter. Make the axis of the microscope horizontal. Adjust the height of the microscope using the height adjusting screw. Clamp the microscope when the capillary rise becomes visible. Now, move the microscope vertically by adjusting the fine adjustment screw in order to make its horizontal cross wire coincide with the lowest position of the concave meniscus, which is seen as convex through the microscope. Note the position of the microscope in the vertical scale by noting the main scale and vernier scale values. Now, carefully remove the beaker without disturbing the pointer. Adjust the height of the microscope in order to see the pointer tip and clamp it when the pointer becomes visible. Again, focus the microscope to see the tip of the pointer clearly. Move the microscope by using a fine adjustment screw to make the horizontal cross wire coincide with the tip of the pointer. Note the vertical scale readings in the main scale and vernier scale. The difference between the two readings will give the capillary rise H. To find the inner diameter of the capillary tube, first place the tube horizontally on the stand. Adjust the position of the microscope using horizontal and vertical adjusting screws to see the inner circle of the tube. Focus the microscope to see the inner circle clearly. Move the microscope to the lower end of the circle. Make the horizontal cross wire coincide with the lower end of the circle by using the fine adjustment screw. Note the readings on the vertical scale. Using the fine adjustment screw, raise the microscope to make the horizontal cross wire touch the upper end and take readings from the vertical scale. Make sure that the movement of the microscope is in any single direction in order to avoid errors. The difference between the two readings gives the vertical internal diameter of the capillary tube. Using the horizontal fine adjustment screw, move the microscope horizontally to make the vertical cross wire touch the left edge of the circle and note the readings from the horizontal scale. Move the vertical cross wire to the right edge of the circle using the fine adjusting screw and take the horizontal scale readings. The difference in the two readings will give the horizontal internal diameter of the capillary tube. From the above readings, we can calculate the capillary rise H and the radius of capillary tube R and thus find the surface tension of water using the formula T is equal to H plus R by 3 into R rho G divided by 2 cos theta. Applications. The cleaning action of detergents is the most common application of surface tension. Surface tension of soap solution is low, so it can spread over large areas and wash clothes more effectively since the dirt particles stick to the soap molecules. Antiseptics like Dettol have low surface tension, so they spread faster.
Okay, clear, everyone?
Yes,
Nimisha, Siddesh, Prathamesh,
Yes, sir.
Bhavna.
Yes, sir.
Okay, so everyone, I hope you have got the idea about that experiment. Mrunal,
Yes, sir.
yes. Okay. So now you can perform the experiment. Again, same type. So this types. Okay, let me share once again. Okay, so by hand, you need to write those two charts as it is: aim, apparatus, introduction, formula, procedure, results, then in surface chart 2. This table only, this is fixed diameter of capillary tube. This is 0.5 mm. This is just fixed. Just write one sentence as diameter of capillary tube. It is fixed 0.5 mm. And this table you need to check. So 3 tables I want with the surface tension value readings. So let's say for 10 degrees Celsius, you have got H1, H2, height difference, and you can calculate surface tension for 10 degrees Celsius. Second case, you need to move that cursor to 30 degrees Celsius. Again, the value H, again, the surface tension value for 30 degrees Celsius. And final, let's say 70 degrees Celsius. The surface tension value for 70 degrees Celsius. The first reading you need to take as a 10 degree, 2 readings with your choice. You can take 20, 30, 40, 50, up to 90. Clear this part? What I want?
Yes, sir.
Okay. So it's 8:55. At sharp 10 o'clock, we are rejoining again. Or you can wait here also if you can. But I want all the readings from all of you. Then and then I will consider as your attendance. Clear? Abhitej, any doubt in the experiment? Atska, Bhavna,
No, sir.
No doubt, sir.
Gagan Kaur,
No,
Pariksa,
sir.
No, sir.
Manish, Nimisha, Prathamesh, Siddesh, then Vaibhav,
No,
please
sir.
tell me.
No, sir.
Okay, so those want to leave,
Yes,
they can
sir.
leave also. And you can rejoin the same link at 10 o'clock. I will post the assignment section on the classroom also, so that you can submit. This is only 2 page, so I request all of you to write down experiment and submit it as soon as possible. So still you have 1 hour, So you can write, you can take those readings. And I want 3 surface tension reading values, 3 height differences, and 3 surface tension value readings.
Sir, we
Clear?
have to just tell the values, or we have to submit the
Yes,
whole
you have
practical?
to submit as you usually do in the classroom. But right now, I just want the
Right.
value, final answer.
Okay, sir. Okay, sir.
Okay. You can write later on also, but I request all of you, this is hardly 2 pages, so you might complete in that time also. But you can take the readings first, then you can write the experiment and submit that handwritten PDF into the classroom. Okay, I will create the assignment in the classroom, so you can submit that section also. But right now, I want the surface tension reading values for 3 temperature readings. Clear,
Okay,
Madhura,
sir.
Mrunal?
Okay, sir.
Okay.
Yes, sir.
Yes, those who want to stay here, they can stay, or you may leave. And please join the readings with your readings at 10 o'clock. Okay.
Yes, sir.
Yes. Okay.